Introduction to IPv6. In this video, I will take you through what makes up an IPv6 address, how to recognize the two main different types of IPv6 addresses, and how they are created in a network. Unlike IPv4, which is a 32-bit address, the IPv6 is a 128-bit hexadecimal address. It's made up of 8 hextets. Each one of them have 4 hexadecimal digits, and that creates a total of 340 uncidian addresses. The two main types of IPv6 addresses you'll encounter are link local unicast addresses and global unicast addresses. There are many more, like multicast and anycast, but for this video we'll just cover these two and how they're created. The first address we'll talk about is the link local unicast address. This begins in FE80, so you can help recognize it. Theoretically, it goes to FEBF. However, best practices says stick with FE80. These are created automatically by the device as a combination of their MAC address to help create it. This address is used only on the local link, which is per the name. A router creates one and then sends a router advertisement message, and the computer creates one, or host, and creates a router solicitation message. They're both on the same network, looking for their own messages to learn how to create their own globally addressable addresses and how to find out who else is on the network. We're looking at a globally addressable IP address on the screen. You can tell because it starts with 200. The /64 at the end tells us that half of this is reserved for the host and half is reserved for the network. The rule is 314. The first 3 hextets are the network. The 4th hextet is the subnet ID, and the last 4 hextets are reserved for the host on this network. In this screenshot, you can see my IPv6 address that was created randomly because I'm on a PC, my temporary IPv6 address, which has a lifespan that will end at a certain point and then recreate itself, so I'm not tracked too poorly over the internet. My link local IPv6 address, now this was created to speak directly to my router, which is enabled for IPv6. You can see here that my default gateway has a very similar link local address, that's FE80, and this here represents the zone for that address. I'm going to take you through a basic setup and walk you through kind of what's going on for this IPv6 network in Packet Tracer. So right now you can see I have the routing set up to no IPv6 unicast routing. Now the routers come default without IPv6 enabled from Cisco. IPv4 is enabled, however, I haven't configured any interfaces here to make that work. So none of this is IPv4, all IPv6. I've configured these routers to have different networks. This you can see is the 1, the 2, and the 3 of a global address, and the 4A is the subnet. The dotted decimals double indicate a whole bunch of zeros and then 1. So that's this network. The FE80 : 1 is the link local address that I've assigned to this interface as well. I was able to assign the same interface on the other side of the router because this only goes out this interface and this only goes out this interface to all these devices. So interesting enough, one router, one link local address on either side. You can see that the PC0 here has a link local address. Now they got this link local address by using the EUI64 process by taking their MAC address, switching the 7th decimal, and creating a link local. Now it starts with FE80 as the standard for link local addresses, and it's waiting to automatically receive the IPv6 address from the router advertisement message once it's enabled. this computer as well. So I can say here, show run to, well, let's exit this interface. And now I can do show run, and we can see what's going on. No IPv6 cert, and it has only link local addresses. And actually, no, it has an IPv6 address as well, but it's not doing anything. It's just assigned. So it's all ready to go. It has router rip. Just need to add the final command. And once I do it, of course, conf t. And now we can do yes to IPv6, but in Cisco CLI, you just type, you don't have to yes, it's actually more specifying no. Hit this, and you'll notice that immediately it enables routing. Since it already has all the addresses set up, it sent out those advertisement messages. The PC got back what it wanted. It created its own address using the EUI64 process, and that has a similar link local because it's part of the Mac. It uses the Mac as well to create this. Now these devices can ping. Everything's routing in green. In the previous example, I showed you how to enable and unenable IPv6 routing. I want to talk a little bit more about the ways the routers send advertisement messages. There's 3 flags. There's the A flag, which is set to 1, means on, and it's automatic. It tells the computer to automatically create its own address. There's an O flag, which is default set to 0, and it has options like default gateway or DNS server or something else that they want to help with the automatic creation. There's also M, which is manual, which is a fully stateful DHCPv6 server message, basically saying go look for that address. You do not create your own. It is possible to leave A and M both set at 1 or on. If you do that, the computer, if it's a Windows computer, for example, will actually create its own temporary IPv6 address using Slack. In a controlled environment, you wouldn't want this because there'd be a random address being created, and meanwhile, you're setting up a stateful server to control the addresses and track everything. So I'm just going to show you really quick how to add that command on the interface here. I have interface G00 of the router set up, and you want to type in IPv6 ND and then manage config flag and hit return. So what I've just done is my advertisement message on this network says you need to look for your own. So if I click this over to static and automatic again, it's not going to get it because it's the computer's. This is now saying, do not get this from me. Don't create it from yourself. Go get your own. Now, if this is a real Windows computer, it would also create a temporary one, but for this purpose, it's not creating one. So, and again, like in Cisco, to undo something, you literally just say, no, you don't want that flag. And I've reinstated the A only. So I can also hit static to refresh it, and boom, it's back to normal. So those are the 3 flags that help with the router advertisement messages. Thank you for watching this short video on IPv6.